Welcome to the Explainer. Today, we're popping the hood on your computer chassis to look at something absolutely foundational. We're talking about the motherboard. And to really demystify how this thing makes modern computing possible, we're going to look at it through a pretty fun lens, treating it like the ultimate bustling city grid of your PC. Let's get right into it.
So, what actually connects your computer? We all tend to obsess over those massive, flashy graphics cards or blazing fast processors, but honestly, on their own, they're just isolated islands of potential. So how does this chaotic, crazy assortment of silicon, copper, and tiny capacitors actually function together as one unified, high-performance machine?
Okay, let's dive into our roadmap for this explainer. First up, defining the motherboard. Second, we'll hit the core components and connections. Third, data highways and power. And finally, number 4, why the motherboard actually matters to you.
All right, Section 1, defining the motherboard. Let's take a high-level look.
At its absolute core, the motherboard is the main printed circuit board in a computer. It connects all the other components and acts as the foundational communication backbone. Basically, it's the physical platform that allows literally every other piece of hardware to exist, operate, and interact seamlessly with one another. Now, this piece of hardware serves a really fascinating dual purpose. On one hand, you can think of it kind of like a central nervous system, right? Just instantly relaying electrical signals from one extremity to another. But on the other hand, it's very much a city grid. It's an infrastructure precisely engineered to organize massive, heavy data traffic without causing a total gridlock. Moving on to Section 2, core components and connections. If the motherboard is our meticulously planned city grid, well, what kind of buildings actually plug into it? Let's look at the core architecture here, because this is where the city analogy really shines. Think of the CPU socket as the factory. That's the massive industrial complex right in the center of town where all your heavy calculating gets done. Next to it, you've got the RAM slots. Those are your short-term warehouses, sitting right by the factory to provide instant access to raw materials. And what about those PCIe lanes? Well, those are basically the loading docks for specialized, heavy-duty cargo, stuff like GPU rendering or AI tasks.
Which brings us to Section 3, data highways and power. We've got our factories and warehouses, but how do they actually talk to each other and, stay powered up?
The answer is all in the physical layers. You have these microscopic data buses, basically little copper traces running all across the board, and they act as intricate highway systems, routing information at the speed of light. Meanwhile, the power phases function as the city's essential electrical grid. They take that raw voltage from the wall and carefully step it down to feed clean, stable power to all those delicate components. Because without these highways and power lines, your incredibly expensive hardware would just sit there, completely idle. Let's actually track a single piece of data to see how this all choreographs into action. Step 1, a keystroke enters the system. Step 2, that tiny packet of data merges straight onto those high-speed buses we just talked about. And step 3, it arrives at the CPU factory for processing. The CPU decides what that keystroke means and immediately fires a new signal out, maybe down to the GPU loading docks, just to display a single letter on your monitor. And the crazy part, this entire journey happens in a fraction of a millisecond.
That brings us to Section 4, why the motherboard matters. Bringing all these concepts together, what's the actual practical application of this for you? The big takeaway here is longevity and potential. Your motherboard completely defines the capabilities of your current system, but even more importantly, it is the absolute foundation for future-proofing your PC. You can't just plug next-generation RAM into a decade-old board. The warehouse docks literally just won't match up. The chipset, the socket type, the PCI generations, all of that dictates whether your computer has room to grow or if you're permanently locked into the performance you have today.
And that leaves us with a final kind of provocative thought to wrap up this explainer. As our components get smaller, exponentially more efficient, and incredibly dense, how is the motherboard going to evolve next? Will the city grid become entirely optical, using light instead of copper to transmit data? Or will everything integrate so tightly that the sprawling motherboard we know today just disappears completely? It is definitely a fascinating space to watch. Thank you so much for joining me today. Keep asking questions, and I'll catch you next time.